So topic 4 is about alkanes and alkenes. In this topic, we will first start with a basic introduction of alkanes and then we'll move on to alkenes. So this topic 4 is actually divided into two parts. One is the introduction to organic chemistry and alkane, and the second part is about alkenes. So what are alkanes, or what is the definition of alkane? As we know, the introduction of a hydrocarbon, that how we define a term hydrocarbon. The term hydrocarbon means the compounds contain carbon and hydrogen only. So compounds which contain carbon and hydrogen, we call them as hydrocarbon. And these hydrocarbons are divided into three main categories, which we call alkane, alkene, and alkyne. What is the difference? The difference is a bond between the carbon atom. If throughout the structure we find a single bond between the carbon atom, we call that as alkane, and the name should end at ANA. Between the carbon atoms within the structure, if we find a double bond, we call that as alkene, and between the carbon atoms, if there's a triple bond, we call that as alkyne. So alkane, alkene, and alkynes, these are the three main classes of hydrocarbons. So first part we'll discuss mainly about alkanes. So what are alkanes? They are known as a saturated hydrocarbon. Here the term saturated does not refers to solubility, it refers to the single bond. Because they have a single bond, that's why we call them as saturated. So term saturated means it contains a carbon-carbon single bond only. The general formula to get these alkanes, that is CnH2n plus 2. So for the hydrocarbons, because the prefixes are important, depending on the number of the carbon atoms, so if you have one carbon, we'll say meth, two are there, we'll say eth, if three are there, we'll use the term prop, if four are there, we'll use the term but, five are there, it will be pent, six, we use the term hex, seven, we'll use the term hept, 8, we use the term opt, 9, it is non, and we can have more than 10 as well here, but again we have to just learn for 10. So for alkanes, as we know, the general formula for alkanes, that is CnH2n plus 2. So where N stands for the number of the carbon. So if I say what is the formula for butane? So but means, the term but means what should be the value of N? Value of N is equals to 4. So we'll substitute, in place of N we'll substitute 4. So it will be C4 H2 into 4 plus 2. C4, 2 multiplied by 4, 8, and 8 plus 2, 10. So C4 and H, 10. So the formula for butane, it is C4 and H, 10. So using this general formula, we can find any of the alkane. And how we obtain, most of these alkanes are used as a fuel, so they are obtained by fractional distillation of the crude oil. So crude oil is basically a mixture of hydrocarbon, and we carry out a fractional distillation. On the basis of the boiling point, we separate the fragments from each other. What is the technique of a fraction distillation, how it is done? So what we do in a fraction distillation, a petroleum, which is mainly a mixture, petroleum or a crude oil is having the same meaning. So which is mainly a mixture of alkane. So mixture of the hydrocarbon with a smaller chain will have a with a similar change will have a same boiling point range. So we add a superheated crude oil into the furnace. So preheated oil is there, then it passes through a column and the fraction condenses at different heights. Because what happened when there are vapors, the fractions, most of the fraction initially in the vapor, they rise, and at a certain height it condenses, the remaining fraction will rise, and at a certain height it condenses, and then it continue to rise until when some of the fractions are not able to convert into the or condense into a liquid state because their boiling points are too low. So they are known as the bottle gases. The fractions which does not convert into a liquid into a vapor state from the beginning, that is the bitumen used for the road carpeting. Then we have a lubricating oil which is normally used for car engines. Then we have a fuel oil can be used for ships. Then we have diesel used for trucks, kerosene or paraffin used for jet fuel. Naphtha is there. It's used in a petrochemical industry for making different products. Then we have a petrol or gasoline used as a fuel for cars. And we have fuel gases or bottle gases which are normally used as a domestic fuel. So what happens? The oil is preheated, then it passes into a column. The fraction condenses at different height. The temperature of a column decreases upward because as the fractions are rising, they are losing energy, so the temperature is decreasing. So the separation depends on the boiling point. The boiling point depends on the size of the molecule. If we have a large size, like more carbon atoms, it will have a high boiling point. So larger molecule will have a larger London forces, like force between the molecules will be stronger. Weak van der Waals force or London dispersion force, that this is the same force which we say between the molecules. And similar molecules, they will have condense at the same temperature, and smaller molecules will condense at the top at lower temperature. And big molecules will condense at the bottom of the furnace at high temperature. So this is how we obtain the fractions from the crude oil. Then normally the fraction which we obtain from the crude oil, they are large fractions. So large fractions are not useful, like they don't have too many uses. The small fractions are more useful. So what we do, we carry out a process which we call a cracking. What is the meaning of a cracking? The term cracking means we convert the large hydrocarbon into a small molecule. So higher relative molecular mass alkanes are converted into smaller alkanes and alkenes, and we can have hydrogen as well. This is a chemical process which involves in a splitting of a strong covalent bond, so it required a high temperature. What are the reasons for catalytical cracking, or why we carry out this cracking? Because the petroleum fractions with a shorter change, example petrol, naphtha, are more in demand than the larger fraction. So we don't find many uses for bitumen, but we have lot of use, like we need lot of petrol and naphtha. So what we can do, we can break the heavy large molecule into the lighter one, and we call this process as cracking. Because the demand for lighter fraction is more, that's why we carry out cracking. And to make use of large hydrocarbon, the supply and the demand for short one should be balanced. The product of the cracking are more useful and valuable than the starting. Example, ethene is used to make polyethylene. and ethane 1,2-diol and ethanol are smaller alkane are used for motor fuel, so which burn more efficiently. That's why instead of using lubricating oil, fuel oil, or diesel, we prefer that car should have a petrol or gasoline, so it can burn that in a small region, it can burn it efficiently. Otherwise, maybe you have seen, like example, when there's a truck or a bus with a diesel engine, because these are long chain molecules, so it's like incomplete combustion likely to occur, and you will find that the bus or the truck which is using a diesel as a fuel is producing lot of black smoke. That is because of incomplete combustion. Is it clear, the concept of cracking and the fraction distillation of the crude oil? Any doubt till this point? Then we also use a technique, we call that as a reforming. What is the meaning of reforming? The term reforming means turning the straight chain alkane into branch and cyclic. Now, when you compare the straight chain alkane, as straight chain molecules, they will have large surface area, so they will have high boiling point. But the branch one, the surface area will be small. The surface area in contact with the other molecule will be smaller as compared to a straight chain molecule. That is why we reform. What is the meaning of reforming? Converting the straight chain into branch and cyclic. That's called reforming. So branch and cyclic hydrocarbon are more cleanly and are used to give fuel a higher octane number, means it can burn easily. That's why you will find like different categories are there. They say high octane. At the petrol station or a gas station, you will find it is written high octane. So what this high octane refers to? This high octane refers to, like, most of the molecules are branched, and as most of the because basically petrol or gasoline is octane, 8 carbon atoms are there. So if we say high octane, it means that we make most of them branches. So when most of them are branches, it can burn efficiently, and you will find comparative price of high octane is higher compared to a low octane fuel. So when we use alkanes as a fuel, fuel is something when we burn it release energy. Alkanes, they can burn rapidly in the presence of oxygen. The complete combustion of alkane produce carbon dioxide, whereas incomplete combustion produce carbon monoxide or a black soot, which is carbon. So the incomplete produces less energy, and the carbon soot can cause a global dimming. And what is the meaning of global dimming? Because overall reflection of the sunlight, most of it will be absorbed, so leads to global dimming. The amount of sunlight which we receive, that will reduce. Then carbon monoxide, what are the problem it can cause? Carbon monoxide is highly toxic and it does not have any smell. So it can cause a death if built up in enclosed space, because our blood will have a is having a greater tendency to absorb carbon monoxide as compared to that of oxygen. So pollution from combustion. What is a pollution from combustion? Normally, these fossil fuels have a trace of sulfur. So when we burn, it produces sulfur dioxide, and this sulfur dioxide dissolve in the atmospheric water and can produce an acid rain. Same way, when we use a coal, which is also having a high content of sulfur, also produces oxides of sulfur. Oxides of nitrogen are not in the fuel, does not have nitrogen, but due to the electrical discharge in the engine, nitrogen react with oxygen and it will produce oxides of nitrogen, and these oxides of nitrogen can also produce photochemical smog as well as global warming. So these are the effect oxides of a nitrogen. It is formed when nitrogen and oxygen react at high temperature and in the presence of spark. An environmental consequence, NO is toxic, can form a smog. Smog is a combination of smoke and form and fog. And it can also produce acid rain because non-metal oxide are acidic oxide. Carbon monoxide is toxic, can cause a death or suffocation. Carbon dioxide contribute to global warming. Unburned hydrocarbon, not all the fuel burn in the engine, that contribute to smog as well. And the unburned the carbon soot, which is the carbon is produced, that can lead to global dimming or respiration problems. So carbon dioxide, methane, water vapors, all are greenhouse gases. They can also absorb the infrared radiation, which leads to average temperature of the earth will rise. So that we will discuss in the next session about the global warming. Is it clear? Any doubt related to the session today? As we started the topic alkane, and we discuss the general formula for alkane, its properties, fractional distillation, cracking, as well as reforming.